So, chapter 3 test. So the first couple of things, okay, the first part was true false. Overall, you guys did pretty good on this. Some people missed C. I just wanted to say a couple of things, and that is if x equals 1, then if x equals 1 is a critical number, there doesn't have to be a relative max or min. Okay, it could be this type of picture right here. All right. Are there any other questions on the first true false section? Okay, so let's look at the second part. This is where some of you, even though I have really tried to get you guys to not do this, if you get to a problem and you don't know how to do it, you can't just go, I've never done a problem like that, I don't know how to do that problem. Okay, we've never done this exact problem. We've done these concepts over and over and over and over again. So, let me show you how I gave you credit. I gave you credit if you just plotted the point. If you just attempted to make a graph, even if the graph wasn't completely accurate, you got 2 points. If you somehow mentioned concavity or drew concave up, you got 2 points. How do we know at the point -2, 5, the function is concave up? The second derivative is positive. At x equals -2, the second derivative is positive. All right, and so that tells me by second derivative test we have a relative min. How could I have changed this problem so that the answer was relative max? The second derivative would have to be negative. Good. Okay, if this really got you down, either because it took too long or you were like real confused, what you've got to think next time you get to a problem like this is just do that one at the end. Skip it and go on with your life. Do the ones you know how to do first. Okay, let's look at problem 3. This was pretty straightforward. Finding the absolute extrema, you have your f of x. Most of you knew to take the derivative, set the derivative equal to 0, and find your critical number. That got you 2 points. You also got 2 points for doing your candidacy table. So let's go through, how did I know to pick 2, 0, and 4? Well, 2 for my critical number, all right, 0 and 4 I got from my endpoints. Your absolute extrema can occur at critical numbers or endpoints. So that's what went in the x column. Okay, in the f of x column, this is the original function. Okay, don't plug this into the derivative. Plug it into the original function. You want to find out the absolute highest point. You want to know the y value. If you had plugged these into the derivative, what you would have been finding is the slope. Okay, and 6 is the answer because the question does say, what is the max? All right, number 4, mean value theorem. When you think of mean value theorem, you need to be thinking AROC equals IROC. Average rate of change equals instantaneous rate of change. So you got 2 points for finding the average rate of change. Okay, how do you find the average rate of change? It's just a simple slope. F of 6. Meaning it's like y2, so you plug 6 in. Okay, y1, you plug 2 in. x2 minus x1, it's just slope formula. Okay, if I connected the endpoints on this graph, the slope of that secant line would be 1/2, and that got you 2 points. Okay, you also got 2 points for finding the derivative correctly. Some people left off the new power. And then the last thing was knowing that what mean value theorem does is set these two things equal to each other. And so you solve for C. Definitely expect something like this on your next test. This was a pretty bad problem. And we've seen this a lot, but we're going to get better and better at it.
Wait, why is the answer squared?
It's not squared, that's just a 2 saying I gave 2 points. It's kind of an orangey color. That's the color of pen I used, but that just helps me know like how to dole out the points for partial credit if necessary. One quick thing is your answer should always be in your interval. If you had gotten an answer, say 1, you know you made a mistake because 1 is not between 2 and 6. Ooh, bless you. Okay.
It's my sneeze.
Yeah.
Others could die in chat. That threw me off. I'm sorry. Natalie, I didn't.
Okay, hold on. I'm having some technical All right, moving on. Number 5. Number 5 ate some of your lunch. This was Trig. You looked at that sign and you said, nope. Okay, we can't do that. There's going to be too much trig in here. It's going to come up every single chapter we do. So A was 6 points. So here's how I doled out the points. You got 2 points for finding the derivative. You got 2 more points for knowing to set the derivative equal to 0. So you got 4 out of 6 points just for that. The last 2 points did come from finding the correct critical numbers. Here's how I did it. I went back to this whole quadrantal angle thing from trig, and cosine represents the first number. All right, so cosine is 0 at pi over 2 and at 3 pi over 2. And then I made a sine chart in part B to figure out increasing and decreasing. On the AP test, they don't really give you points for justification if your answer's wrong. I did give partial credit for that since this was our first test over this. But just do keep that in mind. On the AP test, if your answer's wrong, you don't get the justification points because their thinking is, which makes sense, is you can't justify a wrong answer. So, but sometimes just writing the justification helps you figure out what to do in the problem. So it's never a bad idea to go ahead and write it, even if you're not sure what the answer is. Okay, so that was number 5. It was trig, but it really wasn't too bad. Yes? Will they grade through on the AP test? Yes, sometimes. I think most of the time, yes. It depends on how the people who are in charge of grading that year, what they decide. But yes, I have heard from people who have graded that they do grade through. But if you said that your critical numbers were 1 and 2, they wouldn't grade through on that because those are not even reasonable answers. So that's kind of my understanding. Just if you're not sure, I can look at yours. But I mean, to get full credit, you would have needed both parts. But I can look at it at the end of class today. All right, so number 6 was a polynomial, so no trig in this one. But this one did talk about concavity. You had to find the second derivative, which was 3x minus 6. Some of these fractions got the better of you. The problem with, at this point in this class, if you find the derivative incorrectly, you can't get the rest of the problem right. Okay, so you have to be really careful about finding derivative. That's why we spent so much time on it. And we'll get better at it still. Okay, so we only had one possible point of inflection at x equals 2. All right, and looking at our sign chart here, we can see that it is a true point of inflection, so that helps us with A and B.
Did you plug the 2 back into B?
You plug the numbers to the left of 2 into the second derivative.
Okay.
Because if the second derivative is negative, then f is concave down. Okay, any questions through that? Okay, number 7 and 8 were both kind of similar. They both had to do with can you really think about first and second derivatives? Them being positive or negative, what does that matter? So if the first derivative is negative, that means decreasing for the graph of f, and this is the graph of f. All right, if the second derivative is also negative, that means concave down. Okay, I want to go ahead and write this down here, but some of you remember there was this little chart I showed you guys, and some of you like it, and some of you don't really like to use it. It's not required, but it could be helpful, especially if you got a lot of these wrong. This may be something you want to try and use from here on out. So this says, you know, f second derivative is negative. That means f is concave down. It means f prime is increasing. This is not the graph of f prime, though, so I wouldn't consider that. All right, so that's why the answer is C. What if I change this word negative to positive? Think about that. What would my answer be if both the first and second derivatives were positive? A. So A is increasing. What would the second derivative being positive mean? Concave up. So it would be E. And that's kind of how you'd reason through it. So you can see I could easily change those things and so that we would have different answers. So you might see that problem again. Number 8, it says f double prime is less than 0. That means concave down. So at x equals 0, the graph is concave down. That means it has to be A or B. It can't be C, D, or E. E has a point of inflection at x equals 0. All right, f prime of 0 equals 0. All that means is right there in the middle, we have a critical number. We have a place where the slope flattens out to 0, which is true for A and B. So then we got to look at this last thing, f of 0. What is f of 0? It's the y value. So f of 0 just means what's the y value when x is 0? And if that thing is supposed to be positive, what we're really looking for is this point right here above the x-axis? So the answer is A. If this little inequality symbol right up here had been switched, then the answer would have been B. Okay? So those were kind of testing similar things, but in different ways. And same thing with number 9. Actually, y'all did the best on number 9.
We went over it the day before.
We did do, that was a problem we had done something similar to. So, okay, so we had done a problem like number 9 before. So once you see a problem, you guys are better at it. That totally makes sense. What my goal is to try to get you to see so many different types of problems that even when you get to one you haven't seen before, you can still reason your way through it. So like on number 9, the people who got it right, I saw something like this on their paper. F of 1, that's the y value. Above the x-axis means f of 1 is positive. F prime of 1, that's the slope. The slope right there at x equals 1 is 0. F double prime is concavity. Concave down means a negative second derivative. Okay, then we got to 10, and I knew 10 was going to be a little gross. Okay, because it was tricky. This is an old AP test question. And again, if you saw something like this again, I don't think it would get you. But some people, they just guessed. They didn't have any work shown. This might have been the last one they did. I don't know. But it gives you a function, and it says mean value theorem. So as soon as I see mean value theorem, I'm thinking AROC and IROC. Okay? They give us an interval, and they want to know what f prime equals. Basically, they want to know what IROC equals. Okay? Well, so here's what you kind of got to think. Okay? Let's see, got faded away there. So the average rate of change would be f of 1 minus f of 0 over 1 minus 0. You're plugging this into the original. Average rate of change, that uses the original. So f of 1 would be 5 once you plug a 1 in here and here. Plug in 0, you get 0. So the average rate of change is 5. Okay? The instantaneous rate of change is 4x plus 3. And if we were to complete this problem, okay, like how sometimes it asked us to, we would get x equals 1/2 because we would set the derivative equal to 5. But you don't have to do all of that. In this problem, it does not ask you for the value of C that satisfies mean value theorem. Really, all this is asking is, what does mean value theorem tell us that two things are equal? It tells us that the derivative, which is IROC, is equal to AROC. Once you find AROC, you're done. That's your answer. So if I saw some good work here, I did actually give partial credit. If you circled D, that was the major distractor. If you circled D with no work, you didn't get partial credit. But if you had some work there, I did give you credit because you did do a lot of that problem right. So that one was a little weird.
So it's saying that, like, because they equal each other, that the IROC is going to equal the answer of the
Yeah, it's basically like saying, what are you going to set the derivative equal to do mean value theorem? Yeah, I know. I don't really like that either, but it is. We just got to deal with it. Okay, number 11 and 12, that was that last section that we covered. Okay, and so this was a relatively new thing at the time. Now we should be a little bit better at this because we've kind of been doing this with velocity even. So this is the graph of f prime. This is not the graph of f. I know I've said that a lot of times, but it is not sinking in. When this says at what intervals of f is f decreasing, look on your paper. If you wrote 0 to 1 and 3 to 5 and 7 to 8, you were not considering what they are telling you this is a graph of. You found where the graph of f is decreasing, considering that's the graph of f, but that's not the graph of f. All right? And this is how this question is most often going to be asked. They're going to give you the graph of f prime and ask you about the graph of f. This is where the little chart would be helpful as well. So I had written this on here, but before I scanned it, but let me rewrite it. Again, you may not like this, but like if you got every single one of these wrong, then you need a new strategy. So f is decreasing. So I look in the f row and I say, oh, decreasing, that means f prime is negative. Since this is the graph of f prime, I'm looking for where this graph is below the x-axis. 0 to 2 and 4 to 6. That's how you find those numbers. So notice I'm starting with the justification. This is how we did it in class. That's how I do these problems even when I'm making out the key. So for B, where does f have a relative min? You know, if you look on this chart, I see that f has a max when f prime changes from plus to minus, so I can just switch that around for a minimum. And so a minus to plus, since this is the graph of f prime, I want to know where this graph, as we go left to right, where is this graph changing from negative to positive? Okay. Notice that 3 and 7 are not the answers. If you wrote down 3 and 7, you just, or not 3 and 7, sorry, 1 and 5 and 8. If you wrote down 1 and 5 and 8, all you did was you looked at this graph, and I was pretty harsh with the penalties on that because I really, like, you can't read this as the graph of f. This is the graph of f prime. I know I'm beating this to death, but who knows how many times I need to say it.
It's going to be on the next test.
Yep. There is for sure going to be a question stem like 11 on the next test. And then concave up. Okay, normally for concave up, we'd go because f double prime is positive. But if we look right here, I can see that f prime is increasing. I need to use that because, again, they gave us the graph of f prime. So where is f prime increasing? Where is this graph increasing? Okay? Any questions about that?
I mean, like, I know we can relate this chart to PVA, but
Mm-hmm.
like, are there any, like, tricks that we can learn for, like, building things? Or,
I'm not sure exactly what you're asking.
I'll ask you later.
Yeah, okay. All right, so number 12. This was a table. Overall, people did better at this one. But again, if you got all of these wrong, then it's because you weren't really looking at the rows properly. So for where is F increasing, that's when F prime is positive. The row of F doesn't tell you where F is increasing. Okay, I get that you can kind of look at these numbers, but there's a lot happening between the numbers. So you have to look at the row of F prime. Now, technically 0 to 2 is the best answer because we also had positive like at x equals 1, but I accepted that. That was okay. That was my mistake in making this a question, but I accepted either or. Okay, where does F have a relative max? Well, if you drew these little arrows here, you could see the function moves up, it goes down, and that is happening at x equals 2. Justification though, you've got to use F prime. You got to use calculus in your justification. Your because statement should always be because F prime blah blah blah, or because F double prime something something. Okay, point of inflection was when F double prime changes signs, and that only happened right here at x equals 1. Look at your graph, by the way. Some of you plotted these points nicely, but then you just look to see, did I draw a graph over your graph? If so, I didn't think your graph was curvy enough. It didn't show the concavity. If it was really bad, I probably took off a point, maybe 2, but I might not have even taken off, but look at how it's clear. It's so clear looking at this graph what the concavity is. Is your graph, is it as clear? So that's, you can just kind of self-assess there. And then we have E. Once you make the graph, finding the absolute max is pretty easy. You just look for the highest point.